let's look at a few things right from the start, as we're going to look at some different angles here. So, first one, and again, it's just going to be terminology. So we're going to look at an acute angle. And what's an acute angle? Well, an acute angle is just an angle between 0 and 90 degrees. So if I want to draw an acute angle, it would just be an angle that looks like that, between 0 and 90 degrees. Obtuse angle, well, all an obtuse angle is just an angle that is greater than 90 degrees, between 90 and 180. Straight angle, exactly straight, 180 degrees, so we would say this is the angle here. A right angle is an angle that is exactly 90 degrees, and we use that symbol for a right angle. And then we have two other types of angles that we're going to have some terminology here. If two angles are complementary, what that means is they add up to 90 degrees, and if two angles are supplementary, it means they add up to 180 degrees. So terminology is going to be very important in this section. Now let's look at some more things, some more review as it should be. Now again, it's probably been a while since you've looked at this stuff. So we have two lines that are parallel. And remember, if we have two lines that are parallel, what that means is these two lines will never cross each other. And if they never cross each other, a line that cuts them is called the transversal. What we're going to look at is some properties of these angles, angles 1 through 8. So first of all, vertically opposite angles. Do you remember what vertically opposite is? Is an angle directly across from each other. So angle 3 and angle 2 are vertically opposite. So what that means is if they're vertically opposite, they're right across from each other and they equal the same thing. So if we're looking at vertically opposite angles, we could say that angle 3 is equal to angle 2. We know that that's true. What other vertically opposite angles do we have? Angle 1 is vertically opposite, so that means it's equal to angle 4. We also have vertically opposite angles at the top there. Angle 6 has to be equal to angle 8, and angle 5 has to equal angle 7. So let's look at alternate interior angles. So what does it mean if two angles are alternate interior? Well, just as it is. They're interior, inside the parallel lines, and they are alternate to each other. They're opposite to each other like that. So alternate interior angles would be angle 3, that has to equal angle 8. Those two angles are what we call alternate interior angles. There's also another pair of alternate interior angles. And the other pair of alternate interior angles are angle 5, which is equal to angle 4. Now you may have been taught this before as the Z rule. So if we have this Z like so, those are alternate interior angles. So that might be another thing that you were shown at some point, is this Z rule. So that is the property for alternate interior angles. Now, we also have something called co-interior angles. So co-interior angles are the angles on the same side, they coordinate, and they are inside as well. Now, the thing about co-interior angles is they're not equal to each other, but we know that angle 3 plus angle 5 has to equal 180 degrees. And we also know that angle 8 plus angle 4 is 180 degrees. So we know that those two angles, we don't know anything about those angles, but we know that they equal 180 degrees when we add them up because they're co-interior. The last property we're going to look at and review is corresponding angles. What they mean is it's angles that correspond to the same position in the transversal. So an example of corresponding angles is angle 1, which is the bottom left-hand corner here, corresponds with the bottom left-hand corner of up here. So angle 1 is equal to angle 5 because they are corresponding. The other corresponding angles, well, angle 3, it corresponds with angle 6. Angle 2 is corresponding with angle 8, and angle 4 is corresponding to angle 7. So that's how we know the angles relate to each other, how they relate to each other. So let's look at some other review here. Again, more terminology. Polygons. So we have a number of polygons that we're going to work with. We're going to look at triangles, and we have 3 types of triangles. Of course, a triangle has 3 sides. We have a scalene, and if you remember, a scalene triangle means none of the sides are the same. An isosceles, which means 2 of the sides are the same, and an equilateral, which means all 3 sides are the exact same length. Those are the 3 properties or 3 types of triangles. What else do we know about your triangles? Remember that if we add up all the angles, interior angles of a triangle, they add up to 180 degrees. And the area of a triangle is the base times the height divided by 2, or 1/2 base times height. Let's look at a quadrilateral. Quadrilateral is a 4-sided figure. These are all different types of quadrilaterals. We're most familiar with square, rectangle, parallelogram, rhombus, and trapezoid. You might have to look back. And then we have these other shapes. And again, just reviewing some of the names. 5-sided figure is a pentagon. 6-sided figure is a hexagon. 7-sided figure is a heptagon. 8-sided figure is an octagon. 9-sided is a nonagon, which you'll never probably see. And a 10-sided is a decagon. And these all fall in the category of polygons. So we're going to look at these in more detail later on.